All right, welcome back. We are now on to episode 10. So we're going to be doing something a little different. We're going to be doing some animations today. So we're going to animate our character as well as come up with a class that's abstract enough to handle all sorts of animations in the future. We're going to be working on walking animations and idling animations for today. Then maybe, I don't know, in the future if we want to have like our character dance or have like a sequence of animations, like maybe he moves somewhere, does a jump, something like that. We want it abstract enough to be able to handle those sort of events. But to give an example of what we're doing, this is going to be our game. And as you can see, he stops he has like an idle animation on the right. You go up, he has an idle animation going up, and then down, and so on and so forth. So there you go. We're going to be doing that today. Have them move around a little bit. We're going to download and import a sprite sheet pattern. Let me see if I can actually find that here. Let's go to our file folder. Oh, I should probably do this on screen. I think this is only left, right, down animations. I guess we'll just start with that for now. I have like full 360 animations, like diagonal and so on and so forth, but I guess we could go on to that another day. So let's go ahead, copy and paste that sprite sheet animation. I'll have a link for it in the description if you want to use that. Let's go to our project here, source, repos, game engine, and resources, images, and we'll just paste that. Oh, that's a shortcut. That is not what we wanted to paste. That is very unfortunate. Maybe that'll work. All right, perfect. So let's go ahead, open up our project. I don't have it open right now. I'll shut off my camera too, so you guys can see what's going on here, and we'll just start cracking away. Inconsistent line endings. Oh, I lost my project. I don't know what happened to it. Let's open this again. There we go. Sorry about that. And let's just start off. Let's start off by creating our component system animation. So we're going to have two different systems that we're going to be creating today. One is going to be the system that handles all of our animations. So it's going to go through each frame of every single the frames of what we want it to be animated. And then we're going to have another one that changes our movement animations. And we want to keep those separate, just so in the future, when we do have multiple different kinds of animations, we can kind of mix and match which systems we want to run, and then maybe even abstract that out further to run certain animations at certain points. Especially if we're dealing with like events, it'd be nice to have. It'd be nice to be abstract. So we're just thinking to the future. That's why, obviously, right now they could be combined, and we could definitely do it that way, but we're not going to. System update, and let's just call this animation. So animation.h is going to be including component system. And then let's go ahead and copy and paste. Let's do camera, just so we don't have to rewrite the namespaces and the executes and all that other nonsense. All right, so let's go and rename this to animation. Okay, that is interesting. Animation. And for animation, we're going to need a source. So we're going to be updating the source component of our player every single frame. So let's go ahead and include component rectangle. So we're going to have our source here, and we'll just call it source underscore. It's a private variable. And then let's see here. What else are we going to need? We're going to need an animation map. So we're going to need to include, because we're going to ID all of our animations. So for every single idle, walk cycle, and any other animations that we might want to store, we're going to store it in a map. So it's just going to be a standard hash map. And since we don't actually care about the order, we're going to use the C unordered map, just standard function here. And let's go ahead and define that here, standard unordered map. And it's going to have an ID of a string, or standard string, with the output being an anim. So anim is just going to be a vector of strings. So we could actually create a using here. So using anim is equal to standard vector of component source star. So we'll define anim like that. And then let's give this a name. So we'll just call it anim map. And then we're going to need a variable to keep track of how fast we want to cycle through each frame. So we'll go ahead and define that as float speed. Then lastly, I guess we also need what animation we're going to be currently running. So we also need a pointer to an animation that we're currently running, and we'll just call that anim underscore. All right, so that should do it for our variables. Let's just go ahead and implement our constructor now. So animation, we're going to need source. And then we're also going to need to define speed. So let's just do that here. So float speed. And then let's define our variables here. So source will be lined up with source, speed with speed, and then animap doesn't need to be implemented. Current animation. I guess we could call this current. That's what I call it in my notes. It's a bit easier to distinguish what is going on with that variable name. Current is going to be null pointer, as we do not have an animation set. And then that should about do it. I mean, we could define our animap with just empty brackets, but I think this should just do fine. Valid type specifier. Is that really true? Oh, there we go. We forgot a semicolon. That's why. So we're going to need a few different things to continue on with that. For one, we're going to need the actual time that it's been running. So every single frame, we want to calculate the time and then divide that by the speed to get whether or not we're changing frames or not. So we'll just kind of floor that to an integer, and then as we cycle through, go back to the beginning once we go back. So we'll also modulate it by the animation size. To do that, we're going to need glfw. So let's glfw.h, and there's a function called glfw get time. And we want to convert that to a float, since we're using floats mostly for our variables. So let's go ahead and do a preemptive static cast for float. And we're going to call the function glfw get time. And in the future, we're gonna be dealing with like delta time. If you're new to like video game development, you haven't heard of that. It's just like dividing the frame count by the actual current frame to get everything. You know, if you have like a frame skip, like or just a really laggy event, you can still run your application as if it is running at 60 frames per second. And we'll be implementing that in the future. But for now, we're just going to have everything run at the frame that it's called, as opposed to flooring it or locking it using delta time. But just know in the future we're going to change this so that it runs a bit better. So the next thing that we need to calculate is a variable called animation position. So this is what the frame is at in the animation. If we go to our image and we look at the walk cycle, let me see if I can bring up the image here just to show you guys an example of what we're doing. I guess I could have gone over this in the beginning, but this is the walk cycle, the image of our character. So you can see here the first frame, these are all idles. So these first four are idle down, idle up, idle right, idle left, and these are walk cycles. So we're going to be cycling between these two animation positions. However, there's only going to be one, it's going to be a vector of 1 for our idle animations. Obviously, you can store more, and that you can kind of customize that to your own preferences. But for this particular video, we're going to have very simple animations because it takes a lot of work to draw these. So I don't really want to expend more effort than I have to get this done. So we're going to be cycling between these two animation positions right here. So to do that, we're going to create a variable called animation position. And just like I said, we're going to be modulating it by speed and time. Or we're going to, I guess, multiplying it. I said dividing it. I guess we're going to be multiplying our time by the speed and then modulating that to get our desired frame of animation. So time multiplied by speed. And we're going to modulate that by our current dot size. So this is just a vector. So it's just we're going to get the size of our animation, or how many frames our animation is going to be holding, and we're going to get an animation position. So this is going to return 0 or 1 during a walk cycle, and always return 0 because it's going to be modulating by 1 when we're doing with an idle animation. Next, we're going to have to get the source. So let's just pretty much, we're going to be using our anim position to calculate our source. So to do that, we just do current, and then we can do the at function, which is just the same as dereferencing it and then doing brackets. So at anim position, that should do that there. And then lastly, we're going to set our source dot x and y to our current. So to do that, source dot x is equal to anim source dot x, and then we do that for y, w, and h. So there you have it. This is our animation setting procedure. Obviously, we do not have, we're going to need to add some extra functions because currently we cannot actually add any animations. We're also not checking for null pointers on current, which could be a problem. I mean, obviously you do not want to be running an animation without like setting it first, but if there's no animations to run, this program breaks down anyways. So we're just going to leave it bare and assume that we're going to be adding animations to this. I know that's bad practice, but this is my program, and so it's good practice. It's not actually good practice. You probably should check for null pointers. It doesn't really cost much in terms of performance, but I'm just not going to. animMap.inPlace, and we're going to place our ID in anim in our animMap. And then also, we're just going to set up the current animation as well. So we'll just do that is equal to the animation that we're just adding. So we'll add it in like whatever order, and then maybe, we'll add like the animation that we want playing in the start, at the beginning, or at the end. So let me just do that here. Do ampersand anim. And then the next function we want to do is we want to look inside of our animation map and pull out an animation and then play that animation so that it's currently setting that animation frame by frame to the source. So to do that, we're going to add another function. It's going to be called void play. And this is going to have the parameter just standard string and ID. And all we're going to be doing is setting our current to the animation map at the point ID. So that will play our current animation. So if we want to switch from like idle to moving, that's how we do that. So let's go ahead and figure out our movement animation. So it's just going to be a bunch of if and else statements. So if moving in this direction, we're going to play our movement animation in that direction. Pretty simple. I'll show you how it works once we get through it. So animation system update, and let's call this movement animation. So this is going to be a component system .h. If we can actually spell, that's what it would be. And then let's go ahead and just copy and paste our camera function so we don't have to deal with setting up our namespaces again. Call this movement animation. And for our movement animation, we need access to our component system update animate for animation. And we'll also need access to the controller that we made in the last episode. So let's go ahead and include our component controller. And I believe that should be it. I guess we'll also need access to GLM IVEX, which are just integer vectors. So glm.hpp should just work for that. And yeah, that should about do it. So let's just define our variables here. So we'll need our component controller. We'll define that here. Call that controller underscore. Then we'll also need our component system update animation. Call that animation. So these are going to be specific to whatever character we're doing animations for. So if our player has a map of animations, then like so does an NPC, so on and so forth. It's not going to be like a giant hub for all animations. It's going to be very specific to whoever is being animated with them. Then the last thing that we're going to need access to is this IVEC. We'll just do this IVEC2. So we'll have two different integers, and we're going to call this previous. So this is going to be useful for setting up where it should be idling towards. So this is like pretty common in like Unity. They have something very similar to this. If you've been working with that, if you're looking at like movement trees and animation trees, they use like pretty much an integer to calculate where it was previously animated towards. So let's go ahead and define our constructor here. Movement, animation. This is going to be component iController. Call this controller. And then we'll also need our animation defined. So let's do that here. It's getting kind of long, so maybe move this to a new line. So controller to controller. And animation to animation. And we're also going to set up our previous. So this is going to set up if there's nothing happening on our current frame. We want to set up like the default value. So we're going to have our character default to idling down, or in this case, it's going to be 1 in the Y direction. So we'll set up our previous like that, and then let's go ahead and define our giant if loops. So let's first calculate where we're currently going. So what direction we're going, we're going to do that using our controller to see what is getting pressed down and what's getting or what is left up. So to do that, let's go ahead and make this equal to glm ivec2, and that is going to, we're going to cast our controller presses, which are booleans, to integers so that it casts through correctly. So controller dot key down right. So we're going to be doing with the x direction, so that's going to be minus the integer value of controller. This needs brackets. That should work now. That's going to be minus the controller key down left. And that is off the screen, but that's fine. We'll just have to manage with that. And then for our second pairing, we're going to have down minus up. So we'll just define that here. In fact, let's just copy and paste this. Key down up minus key down down. So there we have it. That's going to be our current. So if right is true and left is true, then this is going to implement 0. So we're not moving in the left or right direction. But if right is true and left is not true, then it's going to be 1 here. And then similarly, if left is true and right is not true, that's going to be -1. So that's going to help for, planning our if statements. So if it's going in the right direction or the left direction, we go and play a certain walk cycle. And then similarly, it works very similar in the y direction. So it could be 1 or -1 to go y. And if these are both 0, it's going to go off the previous value. So the previous value is going to dictate what idle animation we're going to be playing. So if we are actually moving in a direction, our previous value is going to get set. But if we're not moving, previous is just going to stay the same, and we're going to continue to idle in that direction. So that's how movement is going to function. So to do that, let's go ahead if cur.x or cur.y, we want to set previous to equal to the cur because we are moving. And then we just have a bunch of if and else statements to play the proper walk cycle. So if cur.x is greater than 0, animation.play And we'll be playing walk right. Then else if cur.x is less than 0, we want to play walk right, or sorry, walk left. Then we'll have another if-else statement here. If cur dot animation, or sorry, cur dot x or y is greater than 0. In fact, let's just copy and paste this. Replace x with y here because it's the same thing. And then you kind of do a similar sort of thing if you have diagonal walking as well. So you have like walk down right, walk down left, that sort of thing. It's just more if and else statements. So we'll set that up in the future when we want to. I have the full walk cycle for diagonal movement. I think it's in my main project if you want to check that out. Let's walk. This is cur dot y greater than 0, cur dot y less than 0, and this is walk down, and that is walk up. So this else statement here is going to be setting up our animation, or our idle animations. So we'll just copy and paste this here. We're not going to set prev to cur in this else loop or else statement here, but these are going to be the same. It's just going to be idle instead of walking, and it's going to be previous instead of our current. So I'm going to just go ahead and include these into our main file, and we'll go ahead and utilize these in the next episode. Just wanted to make sure that these compile correctly. So we'll go ahead and do that here. Component, system, update, movement animation, and update animation. Let's go to our player object here. Auto. We're not going to actually put them into our update system as they will just error out, but we'll just go ahead and define them here. In fact, let's just copy and paste this twice. Call this animation. Call this movement animation. These are getting a bit long. It's kind of hard to see. Let me move this down just so we can look at it a bit better. And then we'll go to our movement animation here and copy and paste what we're doing in our constructor here. So this has our transform, our controller, and speed. So that is for movement animation. Oh wait, is that move? That doesn't seem right. Yeah, whoops. It's the wrong one I needed. I needed animation. I need to look at this. So this says source and speed. This is animation. Let's call it animation. This needs C+ source. And we need the speed, which we're just going to put as 4.0f for now. We'll probably change that in the near future, but that's just what we're going to go with for now. And then animation movement. Oh, I guess it's movement animation. We can exit out of that now. What do we need for this? Just controller and our animation system. We could even, no, we'll just leave it like so. So we'll need our keyboard, which actually we defined there, so we can just keep that. And then CSU, claw, animation. Should do it. Let's go ahead and see if it compiles, see if we have any errors that we have to deal with. And it looks like everything compiled. We can move around, see if we get any like components not deleting properly. Probably won't. Oh, we did. Look at that. Interesting. There's an entity and a component leak. Wonder where that is happening. Oh well, that's not a big deal. I'll look into that. This video has gone way too long, so just go send it off. Thank you guys so much for watching. In the next episode, we'll actually implement our animations so that we can actually see them on the screen. Thank you guys so much for watching, and I'll see you guys in the next episode.